Assalamualaikum and good morning. So today we will be learn chapter 4, common probability distribution for discrete. Okay. So here the content in chapter 4 part A. So we have 4.1 until 4.3. So 4.1 introduction to statistical probability distribution. Then we have a binomial distribution in 4.2. And the last one is a Poisson distribution in 4.3. So we go to 4.1, Introduction to Statistical Probability Distribution. So let's recall in chapter 1. So you have learned this one. So what is the variable? So under variable we have quantitative, qualitative data. And then under the quantitative, we have a discrete and continuous. So all of this has been learned in chapter 1. So we just recall this. So under variable, so we have a quantitative data here. So in chapter 4, we just focus on the numerical data. And under the numerical, it can be either discrete or continuous. So discrete means that your data is a whole number, but for continuous, your data can be a decimal places. So why we recall this one? Because of under chapter 4, we have the random variable. Okay, so it's related to the variables. So what is a random variable? So random variable is the result of an outcome, okay, that you can measure or count. Okay, so in any experiment, a random variable used to represent every outcome with numerical value. Okay, so because of numerical value, so like I said before, so in chapter 4 we just focus on quantitative data. So under quantitative data, so we have discrete random variable, okay, and continuous random variables. So we have two types random variables. So look at example of a random variable here, okay. For example, we have a Luke. Luke has a stall ice cream. So Luke wishes to investigate how many ice cream was bought in each transaction in a month. Okay, so Luke collect data. So what data? So the total ice cream was bought in each transaction in a month. So this is the data. Okay, so that is the variable. So here we have a table, okay, to show the number of ice cream. Okay, so this is the variable and also the customers. So random variables, so X is a number, okay, number of ice cream a customer orders. Okay, that is a random variable. So this is the probability distribution function. So if X is a random variable, okay, so X is a random variable, function given by Px equal to Si equal to Fx. Okay, so this is a function of X, okay, with the range of Xi. Okay, so look at the table here. So we have a number of ice cream, we have a customers, and also we have the probability distribution function here. So this is the probability. Okay, all of this is a probability. As we know that the probability must be less than or equal to 1. Okay, so the first one, okay, if the number of ice cream equal to 1, so the probability is 0.45. Okay, so we have 1, 2, 3, 4, 5, 6. Okay, 6 probability. If you total up all the probabilities, it should be equal to 1. Okay, must be equal to 1. So here is the representation of the probability distribution function. Okay, so F1 equal to 0.45, F2, F3 until F6. Okay, so this is probability distribution function of X. So we have condition here for probability distribution function. So we have two condition. Okay, so the first one, Px equal to S1, the probability must be greater than or equal to 0. So means that the probability must be positive. Okay, must be positive numbers. Okay, and then the second one, the total of the probability, so this is the symbol for summation, total of the probability should be equal to 1. Okay, so for example, look at this table. Okay, so we have 1, 2, 3, 4, 5, 6, 6 probability here. So all the probability here are positive, and when you sum up all this probability, for example, 0.45 plus 0.34 plus 0.11 plus 0.04 until 0.02, you must get 1. The total must be equal to 1. So that is the condition. So look at example 4.10. Okay, for each of the following, determine whether the given values can serve as the values of probability distribution of a discrete random variable with the range. So we have range 1, 2, 3 until 4. Okay, so remember that we have two conditions. Okay, first one, probability cannot be negative, and another one, if you sum up all the probability must be equal to 1. Okay, so let's look at the solution for the first one. Okay, so check. Okay, the first one is positive until the last one. Okay, so we detect on the last one, so Px equal to 4, we get negative 0.25. So this is not allowed. Why not allowed? Because of our probability is negative 0.25, which is less than 0. So it cannot be a probability distribution function. Okay, so check for number 2. So number 2, everything is positive. Okay, then we total up. Okay, total up this one. So 0.15 plus 0.27 plus 0.29 plus 0.29. So we will get 1. So allowed. Okay, and the last part, okay, everything is positive, but if we total up, okay, so 1.19 plus 10.19 plus 2.19, sorry, 1 over 19 plus 10 over 19 plus 2 over 19 plus 5 over 19. Okay, so you will get 18 over 19, which is not equal to 1. So this is not allowed. Okay, so very simple. So remember that for probability distribution function of a discrete random variable, we have two conditions. Okay, first one must be positive. Okay, and another one is if you total up must be equal to 1. Then we go to exercise 4.11 part A. This one is very a bit different. So look at the question here. For each of the following, determine the constant C. So we need to find C. What is the value of C so that the probability satisfies the condition of being a probability distribution function for a random variable X. So to satisfy the condition, the total, the summation of probability must be equal to 1, right? Okay, so our probability here equal to xi over c. So xi, so we have xi here 1, 2, 3 until 4. So means that you need to substitute this value into the probability function. So we have here for x equal to 1, so it become 1 over c. Okay, so we do for x equal to 2, 2 over c, x equal to 3, 3 over c, and the last one, x equal to 4, okay, it become 4 over c. Look at this one, okay. So when we total up all of the probabilities, it should be equal to 1. Okay, so we total up this one, we will get 10 over c equal to 1. So how to find c? So c times 1, c equal to 10. So this is our answer. This is number 2. Okay, find the c. Find the value of c when the probability equal to CXI. So with xi equal to 1, 2, 3, 4 until 5. So I want you to do number 2, and then we will discuss in our class later. Okay. So we look at the cumulative distribution function. So what is the cumulative? Okay, cumulative distribution function. So it means that the summation of px equal to si must be equal to fx, the capital letter of f. Okay, so before this, the small f, but if the cumulative, it is f, capital letter of f. Okay, so where p, so this is p, px equal to si is the value of the probability distribution of x at xi is called the cumulative distribution of x. So we also have the conditions here. We have two conditions. The first one, so px less than negative infinity, it should be equal to 0. And px less than infinity, it should be equal to 1. Okay. And then if a less than b, the probability of a must be less than probability of b. So this is the condition of cumulative distribution function. Then we look at example 4.11. Okay, so for each of the following, determine the given values can serve as the values of a cumulative distribution function of a discrete random variable with range 1 until 4. Okay, we check one by one here. Okay, for number 1, okay, so px less than or equal to 1, 0.3. So less than or equal to 2, 0.5. Less than or equal to 3, 0.8. And less than or equal to 4, 1.2. Okay, so we check one by one. Okay, so 0.3 is less than 0.5. Okay, and 0.5 is less than 0.8. And 0.8 is less than 1.2. Okay, so the first condition is fulfilled. But for the second condition, when we look at the last probability here, which is 1.2, okay, which is greater than 1. So this is not allowed. The last probability should be equal to 1. Okay, cannot be greater than 1 for the cumulative. Okay, this is cumulative. Look at the second one. So 0.5, so it's greater than 0.4. Okay, the first part is not fulfilled, so this is not allowed. Okay, automatically it's not allowed. And the last part is number 3. Okay, 0.2 is less than 0.6. 0.6 is less than 0.83. And 0.83 is less than 1. Okay, accepted for the first condition. And the second condition, we look at the last probability is equal to 1. So this is allowed. So look at example 4.12. Okay, so find the cumulative distribution function of a discrete random variable that has the probability distribution. So we have this function. Okay, so xi over 15 for xi 1 until 5. Okay, so look at the solution here. Okay, So first, we find the probability of each xi. Okay, so substitute the values of I into this function. So the first x equal to 1, we will get the probability of 1 over 15. Okay, second one 2 over 15. So third one is 1 over 5. So why we get 1 over 5? Because of it is actually 3 over 15. So when we simplify it, we will get 1 over 5. Okay, so we will get this value. So s equal to 4 is 4 over 15, and the last one is s equal to 5. It is actually 5 over 15. When we simplify it, we will get 1 over 3. Okay, so we need to find the cumulative. So cumulative means that we need to sum up all the probability starting from x. Look at here, x less than or equal to 1. Okay, so x less than or equal to 1, the first one here. So 1 over 15. So if x less than or equal to 2, means that we need to sum up, okay, probability of x equal to 1 with x equal to 2. Okay, so x equal to 1 is 1 over 15 plus 2 over 15. We will get 3 over 15. So simplify, we get 1 over 5. So that's why we get 1 over 5 here. Same to the rest. Okay, so x less than or equal to 3 means that we need to plus x equal to 1 plus x equal to 2 plus x equal to 3 until the last one. Okay, the last one is x greater than or equal to 5. Okay, sorry, this one should be x less than or equal to 5. Okay, so we need to sum all the probabilities and make sure the last one you will get 1. Okay, then we have exercise 4.12. So I want you to do this one. So as usual, so later we will discuss all the exercises you have done. Okay. So then we go to mean and variance of a discrete random variable. So how to find the mean and variance? So by using the formula here, look at here. So mean equal to, so this is the symbol for mean. So EX. So this is the formula. So XI, so dot is a multiple. So means that X1 times PX equal to 1. Sorry, this is X1. Okay. And then plus X2 times Px equal to X2. And so on. Okay, until the last one. So this is how to find the mean. So how to find the variance? So the variance here, you need to have the values of mean first. So this is the symbol of mean, right? So you must have the value of mean here. Okay, and you need to find this one first. So the x must be squared. Okay, so summation here. The x must be squared first, and then you times with probability. Okay, and then this one, after you get all the summation here, you minus with the mean square. Okay, so that is the variance. Okay, some properties of mean and variance. So EA equal to A. So mean of A equal to A. So mean of AX. So we can put A outside here. So it become AEX. Okay, A times EX. Okay, so for the variance, okay, you can put outside but with the square. Okay, A square variant X. Okay, so in particular, so the variance B equal to 0. Okay, this is the properties. Okay, so the important is you need to know these two formula. Okay, these two is very important. So how to find the mean and variance for the discrete random variables. Okay, so here is the exercise 4.13. Okay, so look at the question here. So we have the table, the random variable x, the number of ice cream, and also the probability distribution of x. Okay, so what is the probability that one ice cream bought per transaction? So we want probability exactly 1 here. Probability that one ice cream. So means that we need to find x equal to 1. Okay, one ice cream here. Look at the first row. So what is the probability? That is equal to 0.45. Okay, that is number 1. So what is the probability more than 3? So more than 3, okay, means that, so x greater than 3. 3 is not included, right? So because of more than 3, so it's supposed to be start with 4, 5, until 6. Okay, so take the probability here. So 0.04 plus 0.04 plus 0.02. Then what is your answer here? It should be 0.1. Okay, and the last part here, find the mean. Okay, find the mean. So how to find the mean? So by using the formula, so summation, so x multiplied by the probability. Okay, so we have x high here. Okay, so 1 times 0.45 plus 2 times 0.34 plus 3 times 0.11 plus 4 times 0.04 plus 5 times 0.04 and the last one 6 times 0.02. So calculate this and you will get the answer. Okay, so exercise 4.14, so you do this. Okay, so we have example 4.12 here. So find the mean and variance for the discrete function. Okay, so the first one, okay, so we have x 5, 10, 15, 20 and 25. Okay, we times with the probability here. Okay, you look at the solution, then we'll get answer 15. Okay, for the mean. For the variance, okay, so each of the xi must be squared first. Okay, then times with the probability. Okay, then we minus. So we need to find this first and then minus with the 15 squared. So how to get 15 squared? This is from the mean. Then we get 50. Okay. For number 2 and number 3, so I want you to do that. Okay. So this is the solution for number 2 and number 3. So you can look at the solution. So do first and then you compare your solution with the solution given in these videos. Okay, you do your own first. Okay, that's all for chapter 4 in part A for probability distribution function. So next you will be learn for part A, so still under part A, but 4.2 and 4.3 binomial and Poisson distribution. So thank you.